Okay guys, welcome to today's video where we're looking at the numeracy 5 a day, the foundation 5 a day, the foundation plus 5 a day, the higher tier 5 a day, and the higher tier plus 5 a day, okay, from the 31st of May for all of these, okay, ranges of tiers, okay. As ever, feel free to obviously pause the video, guys, and try the questions yourself. So give the questions a go, okay, give it your best shot, and then press play when you're ready to find out and mark your answers, okay, and mark your work. Okay, we're going to start with the first question, numeracy 5 a day. What weight is shown on the scales? Well, here I can see 70, 71, 72, 73. So the answer is 73 kilos. Okay, oops. If I can even write the 3 today, guys. Sorry about that. Okay. Next question. Express 50p as a fraction of £4. Give your answer in its simplest form. Well, it's 50 pence out of 400 pence. You remember that £1 is 100 pence? So 50p out of 400, okay, dividing top and bottom by 50, if you want to do it in one go, yeah, I get the answer of 1/8, okay, because 50 divided by 50 is 1, and then 400 divided by 50 is 8, okay? But if that's obviously a bit of a massive jump, then you can divide by 10 and get 5/40ths, and then divide by 5, okay? So divide by 10, divide by 5 is the same as divide by 50, okay? But I've done it in one go because I'm trying to treat this as like a revision video, okay? To save you time in the exam, okay? If necessary or where appropriate. Next question on the grid, draw a right angle triangle. Okay, so right angle triangle, so it will look something like this, where two lines are perpendicular to one another. Okay, that's a right angle triangle. A triangle has obviously 3 sides. A right angle triangle has one side that is 90 degrees. Okay, hence the word right angled. So right angle means that 2 lines are perpendicular, i.e. that means that they meet, yeah, at 90 degrees, okay, with one another. Okay. This is the 4th question. 2 birthday cards are £2.70 each, one toy is £6.50, and one book is £5.75 each. Nina pays with a £50 note. How much change does she get? Well, 2 lots of £2.70 is £5.40. So £2.70 plus £2.70, or £2.70 times 2. Okay, plus the £6.50. Okay, plus the 575. So let's do this as a column addition. Okay, make sure that we're happy with this. Okay, 0 plus 0 plus 5 is 5. Okay, 4 plus 5 is 9. 9 plus 7 is 16. So 6, carry that extra 1. Okay, carry that 10. Or the ones in this case. Okay, 5 plus 6 is 11. That's going to be 16, 17. So the price is £17.65. If I take that away from £50, well, £50 take away 17 gives me £33. Take away that 65 pence, I get £32.35. Okay. And you can check by doing your column subtraction, okay? But what I did here was a bit of a trick here. I took away £17 first, so 50 take away 17 is 33. Okay, take away 10 and then take away 7. Take away 10, I get 40. 40 take away 7 is 33. Okay, and then I took that additional 65p off, so it has to be £32 something, and that something is 35 pence. Okay, next question. The first spinner is spun once. What is the probability of the spinner lands spin and lands on yellow. Well, the probability of blue is 1/4, so the probability of yellow has to be 3/4, because the fractions have to add together to give me 1/2. Okay, because 1/4 plus 3/4 by definition gives me 4/4. 4/4 is equal to 1/2. Okay, so when I work this out, I get 4/4 or 4/4, which is just equal to 1/2. Okay, remember that anything divided by itself always gives the answer of 1, guys. Okay, probability has to add up to make 1. Okay, next question, guys. So let's just delete that so we can read that. Okay, orange costs, okay, X pence each. Okay, write an expression for the total cost of 5 oranges when I'm going to have 5 X, okay? And I think I have done a question like this before, because I do actually recognise that, but of course, yeah, okay, it's all good practice anyway, okay? Bananas cost Y pence each. Write an expression for the total cost of 1 orange and 1 banana. Well, it's X plus Y, okay? X plus Y pence, okay? Well, obviously, X and Y have to be explicitly greater than 0, okay? Because obviously it costs money, okay? Imagine that you are going to a supermarket, okay? You would obviously pay for that, okay? Next question. Solving this equation, if I subtract 6 on both sides to balance it, I get 4y is equal to 6. Dividing both sides by 4, okay, I get 6/4 or 3/2 or 1.5, okay? Either way is fine. Okay, I'm going to leave my answer as 3/2. But of course, 1.5 or 1.5 is also okay. Next question, solve this equation. Well, adding 3 to both sides, I get 10x is equal to 11. Okay, balance each side respectively. Okay, whatever I do to one side, I must do the same to the other. Okay, dividing both sides by 10, I get 11/10. Okay, for that question, or 1 1/10, or 1.1, okay, or 1 1/10, okay, either way is fine. Next question, the probability of James winning a competition is 0.03. What is the probability that James does not win a competition? Well, it's 1 takeaway 0.03, okay, which is 0.97. Okay, because probability must always add up to 1. This comes from the idea that the probability of an event plus the probability of that same event not happening, okay, or not occurring, has to add up to give me 1, okay? So the probability of A plus the probability of A dash, or the complementary of A, has to equal 1. Okay, next question, rearranging a formula or rearranging an equation, make W the subject, or subtract C on both sides, I get 4W is equal to M take away C. Dividing both sides by 4, I get M take away the C. Okay, it should be a C there, not a 6. Okay, sorry about that, guys. Okay, M take away the C. Okay, all divided by 6, guys. Okay. Next question. I've got the best buys here. 150 sheets is 75p. 400 sheets is £2.08. Which of the two packets gives you the better value for money? You must show your workings. Well, if I do 150 divided by 75, so if I do the number of sheets divided by the price, now in this case I've got to divide it by 0.75, because obviously that's a fraction of a pound. Okay, now working this out, guys, gives me the answer of 20, because 150 divided by 75, sorry, it gives me an answer of 200, sorry. Okay, so number of sheets. Sorry, guys. sorry, it should be 75 divided by 150 here to work out which one is cheaper, or that way is also fine. Okay, I get 0.5 there, or a half. Okay, so that means that it's 0.5 pence of, yeah, to buy one sheet essentially. And then if I do 2.08 divided by 400, that gives me 0.0052. Okay, so that's actually smaller, okay, than that one. Hence, the 400 sheets is cheaper. Okay, because it's 0.0052 of a pence per sheet. Okay. The other way that I was doing it, I was doing the number of sheets divided by that here. If I do that as well, I get 192. Okay, 400 divided by 2.08, I get 192.307. Okay, dot dot dot. That's still bigger. Okay, so that means the 400 sheets is cheaper. Okay, so the regular is cheaper. Okay, the best. So if you ever see that best value for money, it's saying which one is the cheapest essentially. Okay, so hopefully it makes sense. Okay, that's another way of doing it. So the first way actually, yeah, I did 400. Okay, divided by 2.08, okay, and that gave me 192.307, etc., etc. Okay, so 307,692 on my calculator. Okay, that's obviously smaller than the 200, okay, because 150 divided by 0.75 is 200, guys, again, not 20, sorry. Okay, we're now looking at the foundation the foundation plus 5 a day. First question, factorize this quadratic. Well, it's a double bracket, guys. Okay, it's going to be y and y. Okay, I've got a plus and a minus there, so I'm going to have a plus there and a minus there. Two numbers that add to give me positive 3 and that times to give me negative 18. Well, it's positive 6 take away 3. Okay, 6 plus minus 3 is 6 take away 3, which is 3, and then 6 times negative 3 is negative 18. Okay. If you add, obviously, minus 3, yeah, that's where I get there, okay? So y plus 6 times y minus 3. Okay, make sure that you're happy with factorizing quadratics, guys, okay? And leading on from that, it might ask you to obviously hence or otherwise solve it. Okay, if you're interested, if it was equal to 0, then your solutions would be negative 6 and positive 3, guys, if you're interested, okay? But it's just asking for factorize here. Okay, next question, draw this graph. Okay, now before I draw it, guys, I want to answer this question. So what is the gradient of the line? Well, the gradient is the coefficient of x, okay? So it's the number in front of the x. I've got a sneaky minus 1 there, so the gradient is equal to negative 1, okay? So it's going to be in this direction, okay, because it's 6 minus x, okay? Right, guys, so when x is 0, y is 6, okay? When x is 1, y is 5, okay, which is there. When x is 2, y is 4, okay, so I can see that I've got a little line here. Okay, when x is 3, y is 3. When x is 4, y is 2. And when x is 5, y is 1, okay, 6 take away 5 is 1. With a ruler and pencil now, please draw obviously your straight line. Okay, obviously I'm doing a freehand here, but it should look something like that. Okay, obviously doing it in one go. Okay, it's a bit tricky for me because I'm having to do it like a freehand. Okay, but it looks something like that, guys, okay, without obviously the slant there. Okay, so it looks something like that, okay? Next question, what is the size of each exterior angle of a regular hexagon? Well, the formula to work out any exterior angle is 360 divided by the number of sides. Now, I've got a hexagon, which is six-sided shape, 360 divided by 6, and I get the answer to be 60 degrees, okay? So learn the formula that an exterior angle of an n-sided shape, so an n-sided polygon we say, okay, where a polygon is 3 sides or more, okay, is 360 divided by the number of sides. A hexagon is a 6-sided shape, so I did 360 divided by 6, okay. Of course, there is like another way of doing it, but this is like the quickest way here to obviously get your answer, okay. Next question, what is the size of each interior angle in a regular nonagon? A nonagon is, so it's a 9-sided shape, okay. The formula is 180 brackets n minus 2, so n minus 2, 9 minus 2 is 7, 180 times 7, okay, and I get an answer, okay, is 1260, and then if I divide that, because it's saying each interior angle of a regular, okay, divide it by 9, and I get 140, okay. For that question, so 140 degrees is the size of each interior angle in a 9-sided shape called a nonagon, okay. So make sure that you are happy with the names of your different, like polygons that I have, okay. A pentagon is a 5-sided shape, a hexagon is a 6-sided shape, a heptagon I think it's called is a 7-sided shape, a octagon is an 8-sided shape, and nonagon is a 9-sided shape, okay. And I've forgotten the name actually of the 10-sided shape, actually, but obviously, it is like a decagon, I believe, so decagon, okay, is a 10-sided shape, okay. Next question, work out the gradient of the straight line actually that passes through the point 2, 6 and 6, 12. Well, it's a change in y divided by the change in x, so it's 12 take away the 6 divided by 6 take away 2, okay. 12 take away 6 is 6. 6 take away 2 is 4. Okay, so the answer is 6 quarters or 3 halves or 1.5. Okay, or 1.5. Okay, either way will give you the same answer. Okay, we are now looking at the higher 5-a-day, okay, CorbettMaths for the 5-a-day CorbettMaths. Okay, this is the first question. Megan is going to drive 160 miles from Redville to Castletown. There are roadworks for 15 miles of the journey. Megan thinks that her average speed will be 40 miles per hour. Okay, where there are roadworks in 65 miles per hour for the rest of the journey. Work out how long it will take. Well, first of all, speed is distance divided by the time. So to work out time, guys, it's the total distance divided by the total speed, okay, or the average speed. Okay. For that. Okay, so we will have to split this up, actually, guys, into like 2 sets of problems. So if 15 miles actually is going to have roadworks, then she will have 145 miles, okay, where she travels 65 miles per hour, okay. So the time taken for that, it will be 145, okay, divided by 65, okay. Remember that the answer here will give us a decimal, and it will be obviously in hours. So divided by 65, okay. So it's 2.23, okay. So 130, okay. So we'll leave it like that for a minute, okay, Heather. The other part is she will be doing 40 miles per hour for 15 miles. Okay, so again, the time, okay, will be the distance divided by the speed. Okay, so it will be, in this case, yeah, it will be 15 divided by 40. But obviously, yeah, obviously it will be like a decimal here, because obviously, so the way I was going to think of it, guys, is I would add these two fractions together and then just half my answer, because that will give me like a rough time, yeah, an average time of how long it should take. Okay, so 15 divided by 40 is that, 0.375. Okay, plus, so here I'm getting an answer of 2.60, okay, 576923. Okay, I'm trying to get the fraction equivalent. Okay, so the average, okay, so working this out, guys, so I apologize here, so working this out, okay, 145 divided by 65, okay, I can't actually get a exact, okay, so it's 29 over 13, guys, okay, plus 15 out of 40, okay, which is what I put there, so 2.605, okay. Now, because obviously they are not travelling at like the same speed, actually, yeah, for not the whole journey, okay, then we are just going to add, yeah, like the times together, yeah, so that should be the final answer. But it's giving us it in like a decimal, which obviously is a bit nasty, okay, so if you want the actual fraction equivalent, okay, is 271 over 104, okay. So just to summarise, guys, I worked out the time for each separate part of the journey and then just added my fractions together, okay, because that will give me the total time that is taken for the journey, okay. I wouldn't need to half it because I'm not working out an average time, I'm working out the total time that it would take, okay. So that's the total time here, so it's 2.60, okay, hours essentially, okay, so 2. Now, obviously, I can't have like, yeah, like 0.6 of a hour here, so it's approximately, okay, when I have my answer, it's approximately 2 hours, okay, and then 36 minutes, okay, and it has like a decimal here, so it's approximately 2 hours 36 minutes, okay, for the total time for that journey, okay. So that's what I got for that question, okay? Because once you have this answer, then you got to times the 0.60576923 by 60, because obviously, yeah, it's looking at hours and minutes. So it's 2 hours and 36 minutes, okay, roughly. Okay, as my rounded answer. Okay, next question, plot this quadratic graph, so draw this. Now, before I actually draw it, I'm going to work out the coordinates of the turning point by completing this squared. So I'm going to do x take away half of the coefficient of x, so x take away 2 all squared, take away the square of 2, which is 4, and then add the 3, okay. So y is equal to x minus 2 all squared. Okay, take away 1, Okay, so the coordinates of the turning points are going to be 2, -1, okay? And I can use that when I obviously plot my graph, okay? So 2, -1, guys, is going to be here. Okay, and if you're interested, if I factorize this quadratic, okay, I get x minus 1 and x minus 3. That's going to tell me where it crosses on the x-axis, guys, okay? I appreciate that I'm going through this question here fairly swiftly, okay? But hopefully you are happy with this, okay? So it goes through 1 there, and it goes through 3, okay? And it goes through +3 there, okay? When x is equal to -1, I get -1 squared, which is +1, plus 4, which is going to be 5, plus 3, which is 7. So it's going to be up here. Okay, when x is equal to +4, guys, okay, if we're interested, so +4, okay, it will be 4 squared, which is 16. Take away 4 times 4, which is going to be 16, plus the 3, so it's going to end up back at where 3 is. Okay, on the y part. When x is 5, 5 squared is 25. Take away 20, 4 up to 5 is 20. Okay, it's going to be 3 plus 3 is going to be 8. So it's going to cross there, guys. Okay, so again, as she said, freehand, guys, it's going to look something like that. Okay, obviously, yeah, it is like a rough sketch I've done there. Okay, but again, when you do this, obviously, yeah, on your exam, guys, do not, okay, strictly, so don't take your pencil off the paper until you have finished the full curve, okay, for that part. Okay, next question, guys. Given that f of x equals x squared minus 4x plus 3, use the graph to find an estimate for f of 0.5. Yeah, it's going to be about there. Now, this is obviously a bit hard to see on the screen here. Okay, I'm saying that's approximately 1.8, okay, roughly, okay, for my drawing. Okay, obviously, it's a bit tricky doing it on the screen there, but that's approximately, okay. Next part, use a graph to find estimates of the roots of f of x is equal to 4. Well, that's plotting the line y is equal to 4, okay, on here. So it is a horizontal line, okay. Obviously, that's a bit tricky there because I'm doing it in the same colour. But again, use your pencil and ruler to obviously do this very carefully. Okay, so I'm saying roughly x is minus 0.2, okay, roughly. And then x is also about 4.3. Okay, again, they are estimates, so examiners will allow a bit of leeway, okay, plus and minus maybe like 0.5 actually, yeah, for like each part, depending on how you've drawn it, okay, but there is a bit of flexibility and a bit of leeway, because it says find an estimate, okay, so yeah, obviously it is not going to be exact answer, okay, for that one, guys. Okay, last section, guys. We are now looking at the 31st of May higher plus 5 a day. Okay, so this is explicitly for higher tier students only. Okay, I've got xn plus 1 is equal to minus 3 over subtract 5 over xn squared. Start with x0 equals 4. Find x1. So x1, guys, is when n equals 0. Subtract 5 over x0 squared, so it's going to be, yeah, -4 squared, which is going to be 16. Okay, so you will get minus 3 and 5/16, okay, for x1. Okay, I'll try and put it as like a as like an improper fraction, actually, because it makes it a bit easier. So 48 plus the 5 is 53 over 60. Okay, 1. For x2, again, I'm going to have n is equal to 1. Okay, minus 3, subtract 5, all over, this time minus 53 out of 16, all squared. Okay, so doing this obviously on our calculator, because obviously yeah, it is a bit of bigger numbers. Okay, okay, so 53, okay, so I'm going to have minus 3 subtract 5 over 2,809 all over 256, guys, okay, for that one. Okay, minus 3, take away that, okay, so let's do this on my calculator now. Okay, so this sort of question would of course obviously only appear on a calculator, because examiners are not going to require you to work this out, guys. So it's minus 3, okay, take away, then I've got 5 over 2,809, okay, over 256. Okay, so I get minus, okay, 9,707 all over 2,809. Okay, so it is a bit nasty, guys. Okay, so this is looking at what we call like recurrence relation. Okay, so that's obviously worked out that part there. Now working out x3, so let's just delete this now. So now that we've obviously worked out what x2 is. Okay, the idea of this, okay, is that it's getting closer and closer to like a number. Okay, so the next part, yeah, we will look at how close. So minus. So, the next one, x3 is when n is equal to 2, okay, we're going to have minus 3, okay, take away minus 5 all over this number squared, okay, so I'm just going to put an arrow there rather than write it actually, so I'll just put ANS, okay, answer, obviously we will obviously square that number, okay, or that fraction. Okay, so taking our time, guys. So minus 3, take out, and then the fraction button. 5 divided by, and then press the fraction button again. Okay. Minus 9,707 all over 2,809. Okay. All squared, okay, and I get a horrible number, okay, a horrible fraction. I get minus, I think it's 3,200,000, oh no, I think it's a bit bigger, minus 32 million, okay, 129,952, okay. So minus 332,129,000. Okay, 952 all divided by 94,225. So, and then it's going to be 849. Okay. It's unlikely that they will throw something like this in there, because that was obviously a pretty nasty and horrible way of doing it. Okay, but obviously, yeah, it's going to obviously get closer to like an answer, guys. Okay, so minus 3, okay, over 1, then take away 5, then take away 5 all over minus 9,707 2,809 all squared, okay, and that decimal here is minus 3.418, okay, 700, okay, and then etc, okay, 44599. Okay, so Explain the relationship between the values of x1, x2 and x3 and the equation, okay, x cubed plus 3x squared plus 5 is equal to 0. So the idea here is that it's trying to hone in on a solution. So it's trying to obviously hone in to work out a solution. Now this can obviously be rearranged to get it in this form essentially. Okay, this is just essentially rearranging it, okay, in that form. Okay, this just means the next term in my sequence or in my like number pattern is worked out by doing -3 subtract -5 all over, okay, a number squared. Okay, starting with this. Okay, now we obviously worked out what x1 was, okay, by subbing it in to there. Okay, so -3 and 5/16. Okay, so it's giving me an answer of -3.31. Okay, so it's honing in on a solution to this equation. Okay, so what it's trying to do is trying to use a recurrence relation. So it's rearranged to make x the subject here, okay, or x cubed. Okay, it's taken the -3x squared, okay, and then it's taken the 5 over, and then it's divided through, okay, by x squared. So it's gonna have it like this, okay, x is equal to -3 subtract -5 over x squared. Okay, now this essentially is like the sequence version of this. Okay, so this is gonna hone in on a solution. Okay, so you can see the idea now. So I've got xn plus 1 here equals -3 minus 5 all over x squared. Okay, so you can see the relationship here. So it's rearranged to make this x the subject by taking away the 3x squared and the and the 5 over to the right hand side, and then divided through by x squared. Okay. And essentially what it's doing is it's trying to hone in on a solution. Okay, so this is what I call a recurrence relation. So it's picking a random value. So it's starting with x0 equals -4. Okay, to find x1, x2 and x3. Okay, so it's trying to hone in on a particular solution to this cubic equation. Okay, and that the more iterations we do, the closer and closer we will get to a solution to this cubic equation. Okay, or to work out one solution at least. Okay, a cubic equation, of course, has 3 solutions. Okay, now I'm going a bit off topic here. Obviously, if you're doing A-level further maths, then you might recognize that a cubic may have 1 real root and 2 imaginary. But for our purposes, we are not actually focusing on that. Okay, it's looking at the actual recurrence relation. Okay, next question, guys. By drawing an appropriate straight line, use your graph to find estimates of the solution x squared minus 2x minus 1 equals 0. And I've got the graph y equals x squared minus x minus 2. Now, if we look here, guys, okay, I'm going from x squared, right? Subtract x, subtract 2. And I'm going to x squared minus 2x minus 1. Now, the way this is going to work, okay, I've taken away an x and I've added 1. Let's go from here to here. So I'm going to be plotting something involving this, okay? So I'm going to have, okay, y is equal to minus x plus 1. Sorry, yeah, it is going to be x minus 1, sorry, because, okay, I'm plotting, because, so I want to try and make it a bit more clearer here, guys, because if I have x minus 1 is equal to this quadratic, okay, if I subtract the x and then add the 1, that's going to get me to the quadratic that I want, which is x squared minus 2x minus 1 is equal to 0. So I'm going to be plotting the line, okay, x take away 1, okay, that's what I'm going from there to there. So I'm subtracting x and then adding 1, but the graph that I want is the actual reverse sign of this, okay, so it's going to be x take away 1, okay, so 0, negative 1, when x is 1, y is 0, when x is 2, y is 1, when x is 3, y is 2, when x is negative 1, y is negative 2, okay, and then when x is negative 2, y is negative 3, okay, when x is 4, y is 3, okay, so drawing a line, obviously a smooth curve, okay, with a pencil and a ruler, guys, in your exam, okay, where they intersect, that's the solutions to this quadratic equation, okay. So that's how I would solve this quadratic equation, guys. Okay, so draw like a line up here and a line down here. Okay, I'm saying that's approximately 2.4, okay, or 2.45. Okay, and that's going to be minus 0.1, 0.2. Yeah, I'm going to say that that's approximately minus 0.3. Okay, roughly for that. Okay, based on the equation of the line that I plotted, y is equal to x plus 1. Okay, because if I equate both of these equations and I rearrange it to get the quadratic equaling 0, then I will get x squared minus 2x minus 1 equals 0. And then if I wanted to solve it analytically, then I can either complete the square or use the quadratic formula, because it doesn't actually factorize to give me whole number answers. Okay, so I would use completing the square or the quadratic formula. Remember, guys, that if you're doing higher tier, the quadratic formula does appear on the formula sheet, guys. Okay, so make sure that you're happy with that. Okay, last question, guys, for today's video. Okay, so thank you so much actually for obviously watching it, yeah, and making it to the end. Okay, sorry that it has gone on a bit longer than I thought. Okay, a money box contains 4 £2 coins, 3 £1 coins, and 5 50p's. So I've got 4 there. Okay, plus 3 plus the 5. Okay, this is important. So when I look at my probability outcomes, okay, so everything's going to be out of 12 here. 3 coins are taken at random. Find the probability that exactly £3 is selected. So I can have 4, so 1 £2 coin, which is 4 out of 12, times by 2 50p coins, okay, but remember that that's going to go down, so it is going to be 2 out of 10, because once I've taken, yeah, like 11, okay, so I've taken 1 coin, and then I've taken the coin, so it's going to be 2 out of 11 there, guys, because I've already taken 1. Okay, so that's how I get that one. Okay, so it's going to be 8 out of 132. Okay, for that one. Right, starting again, I can have 1 £2 coin. No, sorry guys, I think I actually was correct there, yeah, because if you're taking 2 50p coins, yeah, it will be out of that actually, yeah, so ignore me, so it should be out of 120 there. The reason for that is because I've taken 1, which makes it 2 11ths, but then I'm taking 2 50p coins, so it's going to knock it down another 2, okay? The next option could be 1 £2 coin, and then one £1 coin, so that's going to be 4 out of 12, okay, times 3 out of 11, okay, because I'm taking 1 from there, okay, so it's going to be 12 over 132, okay. I think I made a mistake actually, so it should be an 11 there, guys, yeah, so everything should be out of 132 actually for the exact, okay, for that one, okay. Actually, sorry, so this one should be, sorry, it should be times, and then I'm timesing it, yeah, so it's then going to be, you've obviously got 5 50p coins, yeah, so it'd be, oh, okay, so I think I've actually made this, a bit more complicated than I thought. So your outcomes, guys, are going to be, right, so exactly £3, okay, is made up by doing £2 plus £1, so that's going to be one option. So £2 plus £1, okay, is equal to 3. Okay, another way of doing it, okay, is 3 £1 coins, okay, which is going to be £3, okay. Another way of doing it is a £2 coin plus 2 50p's, okay. So these are my possible outcomes, okay. And then I can have £1 and then £2. No, yeah, £1 and then £2. So this one's going to be in reverse again. I can have £1, okay, plus a £2, okay, in reverse. And then I can have 2 £1, okay, plus 2 50p's, okay. But obviously it actually confused me here. So like, this is looking at like exact probability. So if we start with the key, so let's just start with, okay, so I'm going to select one £2 coin, so that's going to be 4 out of 12. Okay, now there's going to be 11 left over, times 3 out of 11. Okay, because that's going to give me one £2 coin and one £1 coin, which is going to be this one here. Okay, so that ticks off that option there. It's going to be 12 out of 132. Okay, for that one. I can also have 3 £1 coins, so that'll be 3 out of 12, okay, times 2 out of 11, times 1 out of 10, because obviously once I've taken it, then obviously it's not been replaced, okay, as far as I'm aware, okay. So that is going to work out this one here, okay. So I've got 0.25, okay, times 0.1 times 2/11, okay, so it simplifies to 1 over 100, 1 over 220, okay, for that one, okay, so that's obviously deals with that one now, okay. The next one I've put here is 2 £1 coins and then 2 50p coins, okay. So 2 £1 coins, okay, so the probability of the first pound coin, it will be 3 out of 12. The second pound coin will be 2 out of 11, and then the 2 50p's, obviously because 2 have been taken, okay, it will be 5 out of 10, okay, times 4 out of 9, okay, and that should obviously make sense here, because, yeah, I'm taking 2 ever. It doesn't matter which order I do it in, because it's still going to give me the same answer. The other fraction could have been 5 out of 12 times 4 out of 9 times 3 out of 10 times 2 out of 9, the answer would have been the same, okay. So I hope I'm not making this actually like overcomplicated for you guys, okay. Times 4 out of 9. So that obviously simplifies to 1 over 99, okay, and then, so that's going to work out that one, so that's 2 £1 coins, and then 2 50p coins, okay. The last one that we need to do is 1 £2 coin, okay, and then 2 50p's, guys, okay. So 1 £2 coin, which is going to be 4 out of 12, okay, times the first, obviously, 50p coin, so that's going to be 5 out of 11, okay, times 4 out of 10, okay. So 4 out of 12, guys, times 5 out of 11, okay, times 4 out of 10, I get 2 33rds, okay. And they are, okay, the 4 ways of making exactly £3. So just to be clear, guys, 1 £2 coin and 1 £1 coin. So that's going to be this one here. I then did 1 £2 coin and 2 50p's, which is going to be this one here. Okay, I then did 2 £1 coins and 2 50p, which obviously was going to be this one. Okay, and then this one would have been 1 £2 coin, and then 2 50p's, okay, or I think this one was £1 coin, £1 coin, and then yeah, so it was £1, £1, and £1 there, okay, which is obviously, yeah, exactly £3, okay, which is obviously, yeah, the 3 £1 coins. Now, adding my fractions together, I've got 1 over 220 plus, okay, 12 over 132, okay, plus 1 over 99, okay, plus 2 out of 33, okay. So doing that, I get an answer, a final answer of 329 all over 1980. So 329 out of 1980, okay, for that answer there. Okay, I believe that is correct, guys, but if I have missed out like another combination, then do let me know, okay? So just to obviously summarize for this question, I did 1 £2 and 1 £1, which was this one here. I then did 1 £2 and then 2 50p's, okay, so yeah, that obviously gives me £3, okay, so £1 and then 2 of those, which was this one obviously here, as far as I'm aware, okay, so it should have been 4 out of that, and then times by, yeah, which was going to be this one here, sorry. Okay, I then did, okay, 2 £1 and then 5 50p's. Okay, the last one that I've actually forgotten, guys, sorry, is actually if I was to have 4 50p's. No, sorry, ignore me. Actually, yeah. So sorry, yeah. So that's gonna be that one, and then the last one was 2 £1 plus 2 50p's, okay, which was that one here. Okay, and that gave me an answer. Okay, so I've got the each fraction there. That's my first fraction, second fraction, third fraction, and fourth fraction. Okay, I couldn't find any other ways of making exactly £3. You got £2 and £1, £2 and two 50p coins, £1, £1 and two 50p coins. Okay. I could have actually done I've missed out actually one more actually, yeah. So I can do 4 50p coins and then one £1 coin, which I actually forgot. So let's just do that one now actually, yeah. So 4 50p coins, it would be 5 out of 12. Okay, so right then actually, so it'd be 5 out of 12. Okay, times 4 out of 11. Okay, because obviously it's not being replaced, times 3 out of 10, times 2 out of 9. Okay, so that's 4 50p's, which is going to be £2, and then times by 3 out of 8. Okay, so the last one is 1/264. So let's just add on that onto the final answer. Okay. So 1/264, okay, plus 329/1980. Okay, so the final answer in total is 673 divided by 3960. Okay, and that is the final answer, guys. Okay, so we got there in the end, guys. So I got a total of 5 different possible combinations. Okay, right, guys, that's the end of today's revision video for the Numeracy Foundation, the Foundation Plus, the Higher and the Higher Plus. Okay, sorry that the Higher Plus actually took me obviously a while, but hopefully you are happy with these sort of questions. If you did find this useful, please drop the video a like, subscribe to the channel if you're new, and lastly, click that bell icon so you don't miss out on further and future videos. Okay, but this is all appropriate for your papers 2 and papers 3. Okay, for GCSE, Higher and Foundation. Okay, so feel free to obviously dip in and out of the relevant sections depending on your tiers. Okay, but the Foundation Plus, guys, okay, is also appropriate for the higher tier as well, and so is the Foundation tier as well. Okay, thank you so much for watching. Okay. Good luck with your revision, guys. Good luck with your remaining exams, and I'll see you for the next one. Bye for now.